Hey, this is Matt Simpson, and welcome to Notes 4.8. So I didn't want to overwhelm you with way too many problems, but I did want you to practice this concept of simplifying algebraic expressions by combining like terms, and I also wanted to make sure that we practice them with integers. So if you notice in the problems that I've done my best to label what type of problem it was. So like negative 4x plus 9x, those are like terms because they have the same variable and same exponent. But it just doesn't become 13x or negative 13x. They're different signs, subtract, so I keep the sign that is more, so it becomes 5x. Same with like number 2, right? 6y plus negative 8y, different sign, subtract more, so it becomes negative 2y because there were more negatives this time. So what I did is I underlined like terms, I double underlined the other like terms. I also made sure when I went through, changed any minus signs to plus and negative. And any variables that were by themselves, I added a coefficient of 1 or negative 1 in front of them. So take a look at number 7. Right? So we'll have negative, not x, but 1x plus negative 8x plus 7. And then we'll go through and we'll say, okay, I have negative 1x plus negative 8x, negative 1x plus negative 8x, that's SSAK. Same signs, add, keep. It gives me negative 9x, and then I'm just plus 7. The constant has no like term, so you just drop it on down. So what you're doing for the riddle is you're looking for negative 9x plus 7, which is right here, and you're just crossing off that answer. And I've already crossed off the ones that I've done. Let's do one more. Y minus 2y minus 3 becomes 1y plus negative 2y plus negative 3. I have 1y plus negative 2y, that's negative 1y because that is DSSM, different sign, subtract more, there's more negatives, plus negative 3. Now I want you to notice something. We're not going to see negative 1y plus negative 3 in the answers, but we see negative y minus 3, which is the same thing. So you have to recognize that subtraction is the same thing as adding the opposite, and if you see like negative y, that's the same thing as negative 1y. Right? So we crossed off that letter. Let's do one more. Let's do a problem like, say, 22. Right? So I see an x, so I'll put a 1 in front of it, and a y, a 1 in front of it, and then I'll go ahead and change everything. So plus a negative, plus a negative, plus a negative. Let's underline my like terms first. I have 3x, negative 1x, and negative 4x. And then I have 6y and negative 1y. These all happen to be different signs, subtract more. So first, 3 plus negative 1, that's 2x, plus negative 4x, plus 6y, plus negative 1y. And then we can still combine like terms in 2 plus negative 4. Again, different signs, subtract. I have more negatives, so negative 2x. Plus, and then we have like terms in 6y and negative 1. Again, different signs, subtract. I have more positives this time, so plus 5y. So I'm looking for negative 2x plus 5y at the bottom, and it's right here in w, so I'll cross off w. Right? Well, after you cross off all the remaining problems that you'll do in partners after the video, basically what's left over will answer this riddle, and this riddle is, what do race car drivers like to do? All right, let's go to the back side real quick. On the back side we just have a couple different problems. If you take a look at number 2, it says the product of 7 and m, that is going to be one term in your expression. Product obviously means multiply, so that's 7m. Increased by, that means plus, so plus the product of 8 and j, that's going to be another term in your expression, 8 and j, increased by, again, plus the product of 5 and m. That's going to be the third term, 5 and m, 5 and m. And then notice we have like terms, right? We have 7m and 5m, that gives us 12m, and then 8j is left all by itself, plus 8j. So we've translated this algebraic expression from the phrase, and then we also simplified it by combining like terms. You'll be responsible for number 3 and number 4 in Edpuzzle. And then the last part here is we have these rectangles, and what we've been asked to do is to write an expression for their perimeter. So basically what I did in number 5 is I filled in the missing lengths and widths with the same expression, and then I wrote out a very long expression and combined like terms. So in number 6, you will want to do the same thing, 4x plus 2, 5x plus 4. Remember, perimeter is the distance around the shape, so we find that by adding all sides. So we got 4x plus 2 plus 5x plus 4 plus 4x plus 2 plus 5x plus 4. And then you simply find your like terms. So we have 4x, 5x, 4x, 5x. 4 plus 5, that's 9. And then if you had 4 plus 5 again, that's another 9. So 9x plus 9x, it gives you 18x. And then your other like terms are the 2, the 4, the 2, and the 4. So 2 plus 4 is 6, and then you have 2 plus 4, which is 6 again. So 6 and 6 gives you 12. And so there's your answer for the simplified expression for this rectangle's perimeter. It's 18x plus 12. All right, that's the end of the notes. Anything that we have not done, number 7, number 8, probably do an ed puzzle. Anything we have not done, especially on the front, you're going to want to finish up in partners.